Hello folks, and welcome back to the channel. Today we're going to go back with the Pioneer A-008 and see if we can get it out of protection. That's basically all I want to do with this today is get it out of protection. Maybe you rework the power supply while we're in here. Maybe you do a couple of those ribbon cables that need replacing, and not too much else. Reason I'm doing this now instead of waiting a while like I originally wanted to was X-Ray Tony B dropped a video just last week, I think, in which he detailed how the power amplifier section of the SX-1980 works. And since that is a Pioneer unit itself, and I'm working on a Pioneer unit right here, I thought maybe it would be good to get back into this while his video is still kind of fresh in my mind. He basically came to the end of the video and said, if you understand how that amplifier works, you could work on and work out any other amplifier from the era. And this is from that era, I should say. Maybe from the same area too, but whatever. And I figured maybe, now that I've seen his video, maybe I can start figuring out how this amplifier works. Because I really want to do that before I start going in with transistor substitutions, as it were. So, in the time since I did the last video on this particular amplifier, I've been hunting high and low for another Pioneer amplifier that had the same sort of general amplifier setup that this one has. And I only came up with one. That is this one here. This is the SA-9800. This is the blue line version. So a little bit newer than the 9800s from back in the late 70s. Like this amplifier was, but I'm hoping there's enough similarities here to start figuring things out. Near as I can tell, this area here is identical to what's in this amplifier. It's just everything after that area that's a complete unknown to me. I did take pictures of the power amplifiers before I put it back together last time, but those pictures are not detailed enough. I have to get back in there and take more pictures today, and if I've got time, I will rework the power amplifiers to the extent that I can actually use this thing, but transistor substitutions are probably not going to happen in this video, because I just don't know enough about these yet in order to confidently make any suggestions as to what should be used in this. Now, like I said, the first thing is to get this thing out of protection. That's my only concern for this video, and also, like I said, the other stuff. So I will show you exactly what I think the problem is. I actually caught the issue during editing of the last video, but I decided not to say anything or try to reshoot that segment in order to see if anybody else picked up on it, and somebody else did pick up on it. So the issue, best I can tell, is the protection circuit itself. I don't think anything else is the problem, and there's one component in general, maybe you can see it right now, that I think has failed, and that's this capacitor right here. You can see that the jacketing has shrunk away from this. Reason being it's shrunk away from that is it's too close to this gigantic power resistor right here. And with respect to these other power resistors, I have replacements for these. Not because I think they need to be replaced, but because I think I need to step them away from the board in order to keep them from causing a fire or something. Because I should mention also that while we're on this subject, I have found another one of those Japanese service blogs where they have fixed two of these amplifiers. And according to him, these things run at 125 degrees Celsius, so we have to get them away from the board and healthy and happy. And in order to do that, I think I'll be moving two of those resistors to the back side of the board. Not sure if that's wise or not, but I have to keep this area cool, and the only way to do that is to get some of the heat production away from this side of the board. Because honestly, there are not enough ventilation slots in the top cover in order to have them all here anyway. So that's another thing we're going to be doing today, hopefully. But That capacitor right there, I will bet you good money that it's no good ski. So I don't know if I can test it in circuit yet from this angle. I will take a look at the board here. One good thing about these Pioneers is that they do kind of show you exactly where the board or where the traces go, but I don't think I can actually, well, maybe I can. Let me just take a quick look here. Ah, yes, more better light makes more better good. Okay, so the negative from the capacitor goes to this pin right here. I don't know if you can even see that. It goes to that there pin. And where does the positive go? Positive goes to pin 16 over here, it looks like. So I actually can test this right now in circuit. Let's get the tweezers. And we'll see if we can get a reading off that capacitor. See, can you see this? No, you can't. Let's make it so you can. Okay, I'm going to have to spread the tweezers apart to get this. Well, it wasn't designed for this. I hope I don't break it. Okay, 34 picofarads. Yeah, if the circuit board traces on top are correct, then that capacitor has failed. And by the way, I've got a new relay for this too. I know I said I wasn't going to replace that, but I am going to replace it. Reason why is because this comes from Japan, which is already a humid environment. The contacts are probably already corroded, but more than that, this is a high hours amplifier, so I would like to replace that. And I'll show you the replacements by and by, but first I want to get this out of protection, if I can. Not sure if I can at all. And one thing I should mention is we are on the dim bulb. It's over there. You won't be able to see it while I'm using it, but it has to be over there because I need access to my soldering gear. And you'll notice it's plugged in up there now. That's because the old Myruke power meter that I used to use for power supply reviews and will be using again for power supply stuff is up and running. It's working. I'll show you. It's getting power directly from the step-down transformer, so it's getting 101.9-ish volts or so. So we're going to be using that to help us today. That's if our camera gimbal will cooperate. I still haven't replaced it. Don't ask me why. So I need to get access to that capacitor for sure. Let's see, can I get access to it? I think from underneath, maybe I can. So let me just turn this over. And I will get the bottom screws out. Alright folks, this is not going to be very easy to see, but I do have access to that capacitor from here. And it's going to be a bear to desolder it, but I'll just try and do my best here. It's literally right down there, next to a couple of pins for the headphone socket, it looks like. So I'm going to have to heat up the iron, and we'll just get that replaced. And while we wait for that to heat up real quick, I'll show you this. I've got this now. This will be used to service all the potentiometers in this amplifier and many others, but not too many others. In case you missed my community post, or don't see the community post very often, I have two other amplifiers coming in now. They're not here yet. One's the A-006, because it looked like it was perfect for a cosmetic pieces donor for this and the A-012. I'll try and get that one going on its own, but the other one of note is the Trio/Kenwood KA9300. That's their version of the Supreme 600, so very much looking forward to that one. But that particular amplifier is well documented. I know what mods I'm going to be doing on it. I can just copy off someone else's test. I won't probably learn that much from it, but This is the learning amp, and so will be the A-006 when it gets here. If it ever gets here. And another thing I would like to announce is I am very, very much interested in doing another Nakamichi for Christmas. Not sure what said Nakamichi would be yet, but kind of thinking 670, 660, 680, maybe 682, depending on how the money goes. We have 50 volts at 47 microfarads, and I already have the planned replacements right here. These are Nichicon UBT. These are 125 degree capacitors. They were actually ordered for the A-012, but I just kind of somehow knew I would want more than that unit needed, so I bought plenty of them. So we'll just get one of these out now. And then we're going to measure this old capacitor with the East tester, and we'll see what that thing tells us about it. Okay, ECAP mode. We'll grab our capacitator here. And we'll just see what it measures. .25.6 microfarads, so it is about half of what it should be. 9 ohms ESR. So, no good. So we did not get a proper reading in circuit with the tweezers. Yep, polarity is properly marked on the board. That's always something you have to be aware of, is always install capacitors back where you found them, in the same way you found them. Usually works until it doesn't, like I found in the SX-3700, where one of them had been installed backwards from the factory. But we won't talk about that today. What we will do is try to solder the new capacitor in. And then we'll see if we can get this thing out of protection. Is it going to be that easy, I wonder? Okay. I'm probably not going to be able to get this capacitor flush to the board very well in this particular arrangement, but as long as it gets soldered in, I'm happy for now. $108 amplifier. I don't care if it's perfect in every single way. And on that note, the A-006 was even cheaper than this. It was under 40 bucks. I have never spent so little in Japan in my life. Although the Kenwood 880G was about that price, and so was the RSM75 as well. That's another deck we're going to have to get into at some point here fairly soon, but I don't know if it really needs to be done fairly soon. I'm actually not too worried about the disintegrating ribbon cables just yet. It's just you just have to make sure that they're away from where they can short out on anything, and that lead is too long yet, but it's away from trouble. That's all I want from it. It's not going to short anything out. So I'm going to throw the bottom back on, and we'll see if this thing powers up now and clicks into regular operation mode. All right, it is go time. Are we taking bets? Will this power up or not? I don't know. If it doesn't, we've got more work to do. That's all I can say. But I decided to point you at the power meter there so you can see exactly what kind of a draw we're getting off this. The power meter is in before the dim bulb tester, so it's going to have the bulb going through it as well, but that's fine. I just wanted to make sure everything's protected here, so I think we're good. So, does she work? Let's find out. I'm powering on now. Nope, still no relay click. I'll try again real quick here. We're getting about 48 watts, 50 watts, 49. Okay, so that capacitor is not the problem. Something else is. I'm going to leave it running here for a second. And I'll take you down off the power meter because we're going to do some checks here. We're going to check for DC at the outputs, and we're going to do it from here because this is where the amplifier comes in. Let's see, good ground. Where can I find a good ground in this? Right there, maybe? Okay, let's see. Do we have DC on the outputs? Well, not in auto mode. Oh wait, the relay hasn't clicked in yet, has it? Ah, how the heck am I going to test this then? I was really hoping this thing would come out of protection, but maybe there's an issue with the power supply. That would not surprise me at all. I can already feel these resistors heating up here. So I got to figure out where the power comes in, or where the you know, the output from the amplifiers comes into this relay. I got to figure that out. Give me a second. Okay, folks, I had it right all along. That is the actual output from the amplifier modules. So the amp is on its side right now. We're going to just check again. No, yeah, 49.7, 50 watts on the power meter. Anyway, we'll check this channel. It's kind of wandering around there, but no appreciable DC offset. It's not great though. Other channel, same thing. It's just not stable, I think, is what's going on here. And why would it not be stable? Well, all the old parts in the power supply could explain that. But what I kind of would like to do right now is check the voltage rails and see if they're all present. So I guess we'll do that too. See, is that easier to see? Kind of like to show you exactly where I'm probing here. So let's see. You can probably check the main filter caps actually. So power on again. And let's find out here. Minus 35 volts. Plus 35. Plus 35. Minus 35. Yes, the voltage rails are all there. So I think I got to recap the protection circuit and the power supply, and then maybe we'll check again. Because who knows how bad some of these capacitor power supplies are. That didn't make any sense. Who knows how bad some of the capacitors on that power supply are. We've got two power supply cards right here, and one has been getting very, very hot for a very, very long time. So maybe I will go ahead and rework those now. Because we're not getting anything done this way. I suppose it could be the relay has failed as well, but I'm not going to worry about that now. I don't think the relay has failed. It's probably got bad contacts because this thing's so high hours, but I don't think it's failed outright. But who knows? The question is, how can I get in there to rework that board in its current state here? I don't think I can. Anyhow, let me get after these two modules and we'll come back on camera. All right, folks, we're about to do some capacitor checking, and I found some very obviously bad ones. See if you can spot the problem with this one. If not that one, let's see, where's the other one here? I'm losing my capacitors. No, I'm not. Here it is. You see the problem with that one? Initially, I thought this was a little spacer, but no, this one had a first-class Taco Bell blowout. So, let's check these first. Why not? It'll be fun. And I'll show you what I did in the actual power supply. I have reason to believe this thing will be not doing well after I fire it up again. We might be losing some new capacitors. Look at this. 247 picofarads. Oh, wait, let me go to ECAP mode here. Okay, 279 kilo ohms ESR. Yeah, that one's fried. Let's check the other one. This one's one of those ELNAs that I've come to know and loathe. This one is 100 microfarads, I think. No, 35 volts, 10 microfarads. That's right, that's what that one was. And it's measuring 1.5 microfarads, 312 ohms ESR. Wonderful. We'll go to these axial ones now. These ones looked fairly good, but I don't know if they are fairly good. Let's find out. These are 220s. And yeah, those are good. Or that one's good. I might have to put that one back in as well, because I was getting nervous around these axials that I don't put them in correctly when I put them in. But yeah, both of these are good. I figured they would be. I think I got the new ones in right. We'll find out the hard way if I didn't. Okay, next up is 63 volts, 100 microfarads. Getting down towards tolerance, but not too bad. Next one, same value. Yeah, that one's good. Okay, just next one is 63 volts, 47 microfarads. That one's less than optimal, I think. Same value on this one. Yeah, not too bad yet, but definitely going the wrong way. Okay, we got two more ELNAs now, 35 volts at 100 microfarads. $59, that is out of spec. 1.7 ohms. ESR is also not that great. Let's try the other one like it. Well, that one's still good. See the difference there? 0.7 ohms ESR. That one hasn't failed yet. I like it. Not enough to keep it, but I like it. Okay, 10 volts, 100 microfarads. And that one looks good. Now, the resistors. We'll go into auto here and measure these two. This one is 680 ohms. 643, not too bad. This one's 620 ohms. These were all in series with each other, by the way, the 620s and 680s. And that one's kind of dropped. Okay, this one is another 620. It's from the other side of the board. 604, all right. Not bad. And this is the other 680. And that one is very good. So, I have replaced two very obviously bad capacitors. Now, where were they? I will show you right now, if I can find something to point with. And I have found something to point with. You can see what I did with the new resistors. These are actually upsized from the old ones, I think. I believe these were all 3-watt resistors, and that's what the audio blog in Japan said. The latest one I found, that is. And these two here are 5 watts. These two are 7 watts. So they should handle things, but I've got this flopping around loose so you can see the board a little better. And I wanted to point out these transistors as well, because some of them may not be so good anymore. This may be why those capacitors failed. This one's a 2SC1626, and the other one is a 2SA, what is it again? 2SA 816, it looks like. I don't know, I'll have to consult my footage, but you can see back in there I've got 2 of the UBTs down there. Apparently I only bought the UBTs for that board. I only bought Panasonic FR for this board because I figured 105 degrees is still pretty good. Plus I wanted the benefits of Panasonic FRs there. Now the little bad capacitor was this one here, right next to that transistor. Then the other one is this one here, and that is in a location marked for a diode, so I don't know what the deal is there, but let me put this back together now, and we'll see what blows up. I just have this suspicion that I'm going to be losing those 2 capacitors there, the same ones that were testing bad. All right, folks, the moment of truth has apparently arrived. I think I've got all my ducks in a row here. As long as I didn't put those axial caps in backwards, we might be okay. I don't know. I can only hope at this point, but I've got you set up now so you can see all the carnage if those caps vent. But I think we're ready to go. I've got the thing plugged in now. Got the power meter up and running, and let's hit the power switch and see what happens. Nothing. No relay, no nothing. Just checking to see if those cablasticators are getting hot, and they don't seem to be, but I'm going to try again with the IR meter here, or camera, or whatever you want to call it, and I just want to see if things get hot down in there. Those are actually uprated parts from what was in there before, so well, something down there is warm. That capacitor is warm, the little one. Probably can't see it too well, but I think we're looking at venting that one pretty soon. It is a 105 degree part, so I don't know exactly what the deal is there, but what I will do, I think, is I'm going to shut that meter off, and we'll get the big X-Tech meter out, and we're going to check for voltage on both sides of that capacitor. I have 2 clip leads here that I can get in there and clip onto that, so I can hopefully not have to worry too much about having my hands in there when something goes pop, which something probably will go pop. Actually, I'll just screw this. I'll just use 1 clip lead, and I'll just alternate between them with the power off. Okay, so I'll get the positive lead on the negative pin of the capacitor for now. And I need a negatory. Let's see, where can I ground you out? Down there maybe, down there maybe. Let's try that. All right, let's real quick power this up and see what voltage we get. Negative 15 volts. We'll go for the positive side now. See what kind of voltage is actually on this, because I think we're getting close to the problem here. I'm kind of thinking that transistor there, that green one. All right, let's try again. Negative 33 volts. Interesting. Let me see if I can get the actual negative on the capacitor. Let's check there. Yeah, that's backwards. That is backwards, I think. It shouldn't be backwards. Why is it backwards? It's been put in the same way it was originally put in. So what would be the deal there? I think I'm probably going to have to get this whole board out or something to try and figure this out. Maybe I should repeat that little experiment again with the meter and see if there's any heating up of that bottom capacitor, because that one was well blown. I don't care if that little one vents again. Okay, can I see it? Okay, first I'll check the backwards cap. Oh, and you know what? You know what? You knows what? See which resistors are hot and see which resistors are not hot? We're getting close to something here. I think this whole side is gone. So yes. Actually, now that I've seen that, I'm not sure if I need to do any further testing of that one capacitor down there, because we know there's a problem here now. These resistors have not been warm. These have been warm. So this side's working, this side is not working. But I still kind of want to see if I can see anything with this one capacitor that's in the diode location. See what happens here. $50 volts negative on that side, and I can't test the other side because impossible to get to. We're actually making progress, I think. I'm not exactly sure. I'm just checking one more time with the thermal camera. Yeah, the only one that's getting hot is that 10 microfarad part. So where does that connect? Can I even see with the board in? Okay, it's across a resistor. I can see that. And it runs down to a wire terminal. Wait, is that connected? I don't even... Yeah, that's connected. I didn't see the wire at first, but I see it now. So this is the problem child here. It's got reverse voltage on it for some dang reason. And this is the resistor that's in parallel with it. And it goes to that transistor. Yeah, I have to get that transistor out and test it. Oh, this is not going to be fun. Give me a few hours, I think it's going to take me to get this board out in order to really test that, because I got to get down there somehow and desolder those wire wrap terminals, and that's not going to be fun. All right, so the board is out, and I'm about to desolder this transistor for checking. I think that's the problem. I don't know for sure, but I will mention that I was able to test this from the bottom because it goes between this pin and this pin, and there's 50 volts on it. So it should be fine. It's a 63 volt part. And as for why this didn't blow up when it had negative 15 volts on it, or 15 volts on it backwards, it's a 63 volt capacitor. I kind of had the suspicion it was going to go that way, so I decided to drastically overvolt that in order to make sure it stayed good. So I am dead sure it's that transistor at this point, but let's find out, shall we? I got to get it apart or get it out, and we'll check it. If it's not that transistor, it'll be something else. I don't know what else to tell you there. Okay, 2SA816. Let's check it. And I'm going to have to use my old transistor checker because apparently that Finersi one has a bug in the firmware where it consistently misidentifies the transistor pins. So I can't use that for transistors until they fix it, which they have not done yet. But this one should work. It always works. Oh, yes. We have a 2.43 ohm resistor, not a transistor. It has failed. Okay, and with that having been determined, I'm going to go get the other transistor out and check that one too, because if I'm replacing one, I might as well do them both with more modern transistors. And maybe I've actually even got them. I ordered these for the Kenwood that's coming in for its power supply, and as it turns out, oh wait, there's another one here. Okay, we have a MJE 15033G and an MJE 15032G. I bought these for the power supply of the Kenwood, as mentioned, but as it turns out, they're also good for these transistors as well, these big ones up here. I don't know if they actually need to be replaced though, but I can tell you that I don't have enough of them if I have to replace the transistors on this board with them, and those transistors, and the Kenwood. So I might have to be ordering some more of those, but let me just check this other capacitor and we'll find out exactly how bad that one is. These screws are not tight, by the way. Of course they're not. Okay, so that transistor is on this side. Don't forget that. Okay, 2SC1626. What does this one measure? If we can get it in the tester, maybe we'll find out what it measures. Okay, here we go. Ooh, doesn't measure that good on this side either. 1.34 ohms. What the devil is going on with these transistors? Not exactly sure what kind of transistors we're dealing with here, so it could be that that little tester is just reading them wrong. Okay, diode. Can you see this? I don't know. I've got both overhead lights on. Maybe I should turn one off. There, maybe now you can see a little better. Okay, we'll do this side first. Let's see, base is this pin here. Dead shorted. Dead shorted. Yeah, both of these transistors are dead shorted, but mostly dead shorted. So I'm going to put one back in here because I need to know exactly where they go back in. Even though I can usually remember that kind of stuff, I'm not taking any chances with this. So we'll put that one back in circuit and leave this one out until I can find replacements. Or source replacements or some such. Like I said, I don't know if the ones I got for the Kenwood are actually going to work for this. Maybe they will, maybe they won't. Maybe they'll blow up as soon as they go in. Now we'll shut the solder station off, and there are 6 transistors here I would also like to check. Couple of, or 3 Zehners, I guess. I can still check those with the Finersi device, I think, but I just can't check transistors with it till I upgrade the firmware. Or update the firmware, which they have not as of yet. Oh man, you can even see where the capacitor puked all over the place there. Interesting. Okay. Can see where the transistors are, so I'll get the meter again. Might as well do some checks on camera, why not? This is clearly not going to be up and running today, so let's find out. Got another shorter transistor, I think. Yeah, that transistor went to the other blown one. Okay, and I have to retransistor this whole board, I think. Some of them test good, but enough of them test bad that I don't know. And as for the Zehners, I ordered a bunch of Zehners, but they showed up as SMD devices, and I can't use them. So I'm going to have to reorder the Zehners from AliExpress, and I'll replace all the Zehners as well while I'm in here. Maybe even all the resistors too, because this clearly has problems, this board. And there could be problems on the other power supply board as well, but I just don't know for sure. But this is why the amp doesn't come out of protection. Right here. This has to be. So let's see. I want to desolder the one of the others that was blown, and it's a 2SA. I can't even see that. Can you guys see that? It's this one right here. 2SA 893. What's the one facing it? Is that a transistor? I don't even know. K3476D. I don't know what that is. And this other one at the top here, that is unreadable. But maybe now it is. 2SC 945. That kind of sounds familiar from some of the bad transistors lists that I found. 2SA 733, it looks like, on this side. I may actually have those transistors. And this one over here is 2SA 893. Wait, that's the other one I wanted to identify. I'm all confused now. Okay, 2SC 945, 2SA 733 on this side. Okay. So yes, let me pull the that one other transistor and I'll check it real quick. Okay, so I did pull that out and it is in fact fried. So yes, this board has to be thoroughly gone over and reworked, and everything bad has to be replaced. So I think what I'm going to do for now is I'm going to go off camera, start sourcing, see if I can find any possible replacements for these transistors within my stash of transistory goodness. And maybe I can fix this, maybe I can't. I think what I'm inclined to do, though, is I'll try to look for my replacements. I may replace them right now, or I may wait. But what I would like to do, I think, is kick this video live on Saturday so you guys can tell me what you think, because I'm not experienced enough with amplifiers to know exactly what's going on here, or what I should replace some of these transistors with. Okay, update. I think I might actually have the transistors to do the job. The MJE parts I mentioned do, in fact, replace these two. They're overkill for the job, but that's fine. I've got them. These other ones here, I've got the KSC 1845 and KSA 992s. I think those would be replaceable with those. I'm not sure. Again, I have no experience with transistor substitutions, so you guys will have to tell me. I checked all the Zehners except this one. I didn't even notice that one was there. At first, I couldn't get a reading on any of these, so I had to charge up the Finercy tester, and finally I got a reading off them. They're all good, but they check out at 0.66 volts. I'm not exactly sure if they're supposed to be at that voltage, because the markings on them are T5 and then 7F. And logic would tell me that it's supposed to be a 5.7 volt Zener, but I'm not exactly 100% sure. What I will say is they do test good in both diode check and in the Zener test thing in that tester, so I'm not 100% sure if I'm going to be replacing those or not. This one, yeah, I don't know. But yeah, I did want to mention that these resistors appear to have no correlation whatsoever to anything on this board. Like if you follow the traces back here, they go to pins 1 and 2 and 9 and 10. So, well, this one goes to another pin here. And then there are further traces going through these two big resistors here, and I should probably check those as well. I don't have them if they need to be replaced, but I should check them. Actually, let's do that on camera right now, shall we? We'll go in from the bottom. So I think it's probably going to end up being a while before I can get back into this amplifier to actually do any fixing, because I'm just not sure what I'm doing here when it comes to identifying some of these parts or substituting some transistors. Okay, can you read that? Maybe if I zoom in a little. Okay. Actually, there's a bad solder joint on this one. 240 ohms, is that right? Yes, it is. $230 ohms. Okay, those resistors are good. I also want to check these other resistors on the board here, but I'm not too worried about them. I should have replacements for every single resistor if I have to replace them. But they all look good, so they're probably not bad, at the very least. I should have left this on and just checked them with you right now. I'm getting tired of working on this amp already. $16K on that. In circuit, of course. $15K there. $3.6K. About 10K. Yeah, that looks right. I know those resistor color codes line up to that. About 15K on that one. I can check the color codes later. I'm not too worried about it. But yes, this is why the amp doesn't work right here, this board. I don't know what happened to make it not work. Maybe they were cranking it too hard one day and blew these two up and killed a bunch of these other transistors in the process. But whatever. Alright, so one last little update before I go off to bed, because I decided to work on this a little bit more this evening and do some other stuff, and check this out. I got that fixed. I'll show you how I fixed it too. You can see it right there. There is now a coupler in there instead of the plastic one that was in there before. This one just barely works. I had to drill out this side in order to get it over the shaft because it's just a little bit too tight to go on, but it went on and I'm no longer having to deal with this thing. I got a bunch of those things right here. They're 6mm flavor, so that's what you need. And I've got these as well. These are U-joint types, and I think I would rather have these in here, but in order to get the U-joint type in there, I think I would have to probably either take that switch out or take the shaft out from up front here. Maybe I can do that later, maybe not. Anyhow, another thing I've done is I've measured all of the pins for both this board and this board, and this is what I got for that. These voltages are for the board that's broken, and these are for this board right here. I think everything on this board is working, and obviously everything on this board is not working. The resistors, I am fairly sure now, are for the illumination on this unit, and by that I mean these lights up here. Those don't work. None of them work. So the low voltage power supply being out would certainly explain that, and I think that's what we have here, is just a low voltage power supply for some of the auxiliary voltages on the amplifier. I think what that circuit powers is most of this circuit up here, probably all of this over here, maybe some of the amplifier boards. I don't know. There's a lot that it apparently powers that is not getting power right now because this thing is blown up. So I'm thinking what I'm going to have to do is yeah, like I said earlier, or may not have said earlier, I don't know at this point. I've been working on this all day. I think what I'm going to do is I'm just going to leave this out like this so I can study it. And maybe once I figure out what the circuit is doing, then I can attempt to fix on this. I think I actually have all of the transistors I need to fix it, but not exactly sure. I might have said that too. I don't know. It's been a long day. What can I say? So I think the next step tomorrow morning or afternoon is to go through this. I want to check some of these transistors, and then we'll get into the power amplifier module, and I'll try to take my pictures there, and then we'll call it a video from there, I think. With regards to the Zehners, I have now found out that this tester cannot test Zehners either. Well, it's actually even worse than that. It doesn't test Zehners, and it doesn't test the IR decoding either. None of this works properly at all. This was a complete waste of money. So what I've done is I went on AliExpress just a few minutes ago, and I ordered up an updated version of this one. This one does everything short of testing Zehners. I'll show you what it does if I can get to it. For starters, you can change the colors of the display. Okay, here we go. We've got, if you can even see that, we've got a frequency counter, function generator, 10-bit PWM, bunch of stuff here. I don't know exactly what all this is, but yeah, it does everything short of test a Zener. So I gotta have something that'll test a Zener because I don't want to do the homebrew solution. too much. I'd like to have an all-in-one test box that actually works for that. Like this was supposed to, but doesn't. So I'm very thankful that my oscilloscope from Finersi works, and I'm very thankful the tweezers work. Probably all I'm going to be buying from that company for quite some time now. So yes, let me go get some rest and some shut-eye, and we'll come back tomorrow and deal with all the stuff I said we were going to deal with. Okay, I'm back at it early in the morning, and I have gone over the transistors on this board now, and we have one potentially bad MOSFET here. At least I think it's a MOSFET. It's this guy right here. I've got a dead short between the drain and the whatever the middle pin is. I don't know at this point, but you can tell it's a MOSFET because it's labeled drain. So I don't know what to replace that with, but I think I will want to replace that. Just happens to be an unknown as to what I would replace it with, but everything else seems to test okay on this board. I tested all these diodes up here. They're good. And every transistor but that MOSFET tests good. So I don't know. I think there's another one of those MOSFETs on this side, but not sure. But just taking a quick look while I got you on camera here. Let's see, do I see a drain marking? Yes, I do. This one is a MOSFET right here. So maybe I double check that one on camera with you. It's already a long video anyway, might as well make it a little bit longer. If you've watched this long, I'm guessing you don't mind a few more minutes of action here. We'll use that meter again. Let's see. The equivalent pins on this MOSFET would be these two over here. Okay. I'm actually gonna start thinking those are good, but I may pull them out and test them more thoroughly. I think my transistor checkers can do that, at least this one. I don't know. I'll worry about that another time. What I want to do right now is I want to get into the power amplifier and start trying to figure out what connects where on that, because what I want to do primarily is I want to see if these two are in the same position in the circuit that the SA9800s are. So give me a second and we'll get one of these amp modules out and we'll take a look at that. Alrighty then, now we have an amp module and we can take a look at it. So what I'm noticing first is this is going to be the filter here for whatchamacallit. I don't know. I can't think straight today. Anyway, this is an AWH 070A, it looks like on the board it's marked. And I can tell already that these are the emitter resistors for the 4 output devices on this channel. And another thing I can tell is we got the long tail pairs over here. This here would be the 2SC2291, I believe it is. I'll just check with a flashlight. Yeah, that's the 2291. This here will be the counterpart to that, so it's most likely to be the what is it on the 9800? Q4 2SA979. I may actually be able to replace those, but I would have to do the double transistor kind of conjoined twin thing that X-Ray Tony B has detailed on his channel with some of my newer ones. I'm not exactly sure if there's a need to do that yet. I don't know if these transistors go noisy or what, but anyhow, this one's going to be encapsulated for thermal reasons. I'm not sure if I need to do that on the replacements, if I do replacements. This transistor right here is, what is it? Unreadable. I have no idea what that is. I can't read it. Let's see if you guys can read it. SC 1775. I don't think I want to pick you up off the stand anymore because it's kind of a pain to do it. So, is it on this schematic here? That transistor, what's Q2? Q2 is 2SC 1775. Yep. That is that transistor right there. So that part and the two long tail pairs are the same as what's on here. However, we've got 3 potentiometers here and only 2 on this board, so there's obviously going to be some differences here. Okay, now what else? The 2 potentiometers, I actually have those now. Those are going to get replaced with multi-turn pots to make it easier to calibrate. At least that's the plan. Okay, so what other transistors do we have here? This one here, 2SC 1885, and it looks like there are a few of them. Yeah, that's another 1885. 2 1885s. What's this one? 2SA 912. This one over here is a 2SC 1885. I remember that from my pictures. This one's a 2SC 1913, and this one here is a 2SA 913 with a 2SA 912 right next to it over yonder. These 4 transistors, I think, are in the overcurrent circuit. 2SC 945, 2SA 733, 2SC 945, 2SA 733. Yes. I believe that's what those are. And yes, this SA99 or 9800 has those transistors, those same exact transistors. So, where in fact do these connect? On the SA9800, they are Q36 and Q34. And what they do is they connect directly to the output transistors. Not sure if they connect exactly directly or if there's through some other component, but let's try and see where they connect on here. Okay, the emitter of Q36 and the collector of Q36 all go off the board, probably to those output devices. And then the base goes back into the amplifier somewhere. So, which is the base on this particular transistor? It is marked on the board, but I'm having trouble looking at it. Okay, the base is on the far end here, so these other 2 pins theoretically should go right to the output devices if this is the same type of circuit. That's what I'm thinking there. I may have to study this in more detail later. Okay, so this here looks like it's the collector, and it goes off down here through 2 jumper wires down here to a diode. Let's see, where else does that trace go? Comes over here to this capacitor. And what else does it do? Goes through a resistor to this transistor right here, the 2SC 1885. So yes, it is a different circuit than what we're dealing with in the 9800 there. So where does the emitter go, I wonder? I can't tell because the trace is not marked. I have to get this board off in order to find that. Great. Okay, so the emitter goes from here, down to here, and over to these two traces here. What do those do? Oh yeah, those go right to the outputs. Those go right to the emitter resistors. For the outputs, I should say. Or at least that particular transistor does. What does the other one do? Same thing. It's just backwards because it's the other side of the circuit. Do I find the same thing there? It would appear so. So yes, it is roughly the same type of circuit that's going on in the SA9800, which by the way does have ring emitter transistors of its own. It just doesn't have the same ring emitter transistors as this amp does. So I don't know exactly if this is a one-to-one match, because like I said, there are 3 pots on this circuit and only 2 in this one. But this looks very, very similar to me now. This entire circuit. So I gotta take my pictures now, I guess, and then I'll conclude the video. I could possibly just remove one of these amp module boards, but I don't think I want to do that because I want to keep track of where everything goes. By the way, I have tested these output devices multiple times. They're all good. At least on a multimeter. I don't think they're bad at all. I think every single one of these ring emitter transistors is good. On both sides. And I could be repasting these now. Actually, I've got sill pads for these, but that's something we'll save for the next video in the series, I think. Whenever that is. I don't know. I'm real close to ordering some of those new, or some more of those new MJE parts already. Anyhow, I will conclude the video here. I'll give you one last good look at the board here, so you can see the power amp board and how it looks. Maybe you can help me with identifying components here. Maybe not. It's starting to look much simpler to me than it did even just yesterday, so I will see you in the next video. Take care.